Okay, I'm going to talk to you today an uplifting, keynote-like tale full of despair, frustration, lack of the will to go on, and realizing that everything you've worked for decades has flopped and has failed. But just in case that worries you, in case you think I might lack optimism, it's a 35-minute talk and I have 85 slides. That makes me an optimist. Okay, so this is me, just to check. Yes, I am. Okay, and this has already been said, so I don't need to do that. So that's great. So we're up 6 slides already. Excellent. So what are we going to talk about today? Firstly, explain to you how standards are made. There's an old joke, standards are like sausages. Your enjoyment of them is increased by not knowing how they are made. I'm going to talk a little bit. I'm going to give you 4 case studies of standardization and how it worked out in practice. Firstly, WebAssembly, then WebVR and WebAR. And then I'm going to go into a bit more detail about color on the web and about fonts on the web. And lastly, hopefully, some sort of conclusions that you can take home to benefit from this harrowing experience. So, standards. How are standards made? Well, if you've ever worked in open source, you'll have an idea how this sort of thing works. You know, you start working on something, and after a while, other people join in, right? You have this idea, and then you're doing it as a side project, so you stop for a while, and then maybe you get back on, and you try to do it some more, and you think, oh, this is going to work this time. And then someone else joins in, and they're really enthusiastic, and they really run with it. And after a while, you're sort of thinking, but I was going to do it like... But it all works out in the end, and we're all friends. That's great. This is a quote. It's from 1995. It was made just off the cuff, it got minuted. Someone said, maybe when there's 2 areas of different colors overlapping on the screen, we could sort of blend them somehow rather than one of them just basically knocking out the other one. And in 2015, we ended up with a specification to define how to do that. That was quite a long wait. Here's a little bit of the CSS layout language, which was a proposal that predated CSS. It's from 1995. It's easy to skip over these things. Geometry with an area, and then flow. And it says the receiver of a certain flow, a part of the HTML document, will go from here. And if there's too much, it goes over here. Just like desktop publishing. Yeah, we didn't have that. And then we had it, and then it got implemented. And then the implementation got removed because it was seen as a bad idea, and we still don't have it. So that's where we are now. All right, let's talk about WebAssembly. How many people here have heard of WebAssembly? How many people have used it? Yes, it's firmly in the good idea. I should look at that stage, right? So what does WebAssembly do? Well, it's cross-platform. That's one thing. You don't have, here's the Mac version, here's the Linux version. It's one platform. And it's secure, and it's sandboxed. It's running its own little container. And it's statically typed, which is a good thing, probably. Let's not have that argument now. And it's binary. You don't have to parse it. You just download the thing and start executing it. And when I'm looking at this list of benefits, it kind of reminds me of something. There used to be this thing called Java, which the elder among you may remember. It used to even be in web browsers. And there was a language, and it compiled to a thing called the Java virtual machine. And then people realized, hey, a compiler's a compiler. I can take my favorite language and compile it to the Java virtual machine as well, which would then be cross-platform and would be secure and sandboxed and statically typed and binary. So we tried that once. It didn't work. We're now doing it again. There were some experiments, and eventually the different people who are prototyping this, extending JavaScript for performance, as I said, while breaking it a bit, ended up getting together and producing this. So, okay, good. And then what happens? So W3C now, if you have an idea, and it's a little early for standardization, you can form a community group. which you can do in about 24 hours. You just need to have 5 people who say, I want to do this, and work with you, and you make one, and off it goes. And they made a community group. They worked on it a bit more. Then they created a working group 3 years ago, and now it's becoming standard. So what's the difference here? So the JVM was not designed to be a multi-language target. It just happened to be usable as one. And the one company that owned the technology said, we don't want you doing that. Don't do that. The difference is, with WebAssembly, it's designed specifically to be a multi-language target. It has a consensus-driven process rather than, here's our new version, you will use it. And it has multiple implementations, which is always good for interoperability and for making sure that the specification actually defines it rather than whatever someone shipped. So there's a few differences there. But apart from that, yeah, honestly, it really is the same thing. Web, VR, and AR are very hot nowadays. You'll have seen lots of people wandering around with these goggles on at this very conference. So 3D, it's a brand new idea, right? Having 3D worlds and being able to interact with them. Like this incredibly fanciful stock photo, which honestly, it doesn't work like that. But still, anyone remember VRML, virtual reality markup language? Hey, we've got HTML with these tags, and we can write stuff, and it puts things together. Let's do that for 3D as well. That'll be a good idea. 1994. It had static 3D worlds. You could define a model. It had hyperlinks, so you could link from one place to another, and you could sort of suddenly go over here, look at the laptop from the side, and come back. Woo! That's it. That's your interaction. And you could move the camera around, and that was about it. What was the problem? Why wasn't it wildly successful? This is, if you were a high-end gamer and had lots of money, this is what the card you would have. It was a 3DFX card. It was super powerful. It was not. It was barely able to run even the games at the time. You'd have to tweak things and turn everything off and et cetera. It was awful. And most people's computers didn't have one of these in them. Of course, a computer at that point was a big thing like this that sat underneath your desk. I mean, there were no laptops or anything at that point. So this was just not capable of doing what people imagined in their heads it would be doing. So the end result was a bit rubbish. If you compare that to this is a modern, much, much more capable GPU on a phone, a low-end phone. So we now have some of the capabilities to do the things we want. VRML did have events. It sort of had a script node. It didn't really have a DOM exactly as such, but there was this escape hatch. You could extend it a bit. And people did, and they put in their own special viewers. This was in the days when if you wanted to view some content on the web and it wasn't HTML, you needed a viewer to do it. Right? If you wanted to listen to sound, you had a sound viewer app. And if you wanted to look at some 3D stuff, you'd click a link and some other program would launch and let you do your 3D stuff. And it soon got to be only follow this link if you got this one installed, but not this other guy, because that one doesn't do our extensions. So it ended up most content was specific to one particular implementation. There was no interoperability. And there was this wasn't even imagined, the idea that you would have 3D goggles and that when you move your head, it would actually know where you were, all of that sort of stuff. Input and output. So WebVR, what does WebVR do? Well, first of all, it can detect, when you start it up, it can detect what devices are plugged in and what they can do. And also where the stage info is. If I'm in some 3D model of this room, it's kind of helpful if I know that if I step forward 2 more steps, there's going to be a problem. Instead, I'll get warning, warning, just before I crash to my death. And poll the device's position so that when I go like this, it knows that the world hasn't moved, but I have moved. And display imagery with a fast GPU. So we had a workshop. This is another way that W3C moves things forward. We had a workshop. Oh, my gosh. Is that how much time I've got left? OK. We had a workshop on web and VR. And the workshop came out with a report which said, what do we need? We need 360-degree media integration, not just flat videos, but wraparound videos, so we can then orient them with 3D content. Immersive audio, so you can hear things coming from behind you or whatever. And a VR mode for CSS media queries, so we can parameterize stuff, and a Skybox API. And we need to take into account input as well. So that's AR and VR. That's coming up quite nicely despite the earlier failures. OK, color. Why should you care about color on the web? I mean, we've all got color, right? OK, have a look at this screen. Have a look at the screens at the side and tell me honestly with your hand on your heart that these are the same color. No, they're not. So what happened in prehistory when I was just starting? Well, this is what we used. We used a monitor, and it had maybe as many as 256 colors, a little palette, and you gradually use them up, and it's like, no, we can't display any more colors. When I first started working at W3C, I was one of the only people there that actually had a true color monitor. And they all had different gammas, and so you'd get this site looks best on a Mac, and this, that sort of thing. It was terrible. So we had a workshop, as I've mentioned. We have these workshops, and this was actually my first month at W3C. We had a workshop on print, and one of the proposals there was a standard color space for the internet. It was based on the same standard that's used for HDTV, so it was reasonably easy to deploy. And largely because I insisted, the first edition of Cascading Style Sheets said that all of the colors are sRGB. We then had a huge hand-wavy thing of course, you may vary in your fidelity to actually do anything about this information, but honestly, this is what they're meant to be. That was as good as we could get at the time. So color-managed screens arrive. I mean, they gradually, first on the Mac, and then Windows properly, and then Linux eventually, and so we're great. It's like we've got color management systems on all the platforms that people use to browse the web. Hooray! Except then mobile happened, and it's like, no, color management on a phone? Come on, you're kidding me. So we were back in the... So this was the point where I was like, I've been trying to do this for about 8 years now. Why isn't it happening? I might as well not try. So it requires a bit of reflection. In industry, color management is super popular. Enormous industries run on the basis of using it. What's the difference? Well, there's a customer, first of all. The customer is paying money. The customer will also charge you money if you get it wrong. The design is finished and then handed over. It's actually signed over. This is the finished, no more changes. And because large amounts of money are changing hands, the cost of having a couple of thousand pieces of equipment to measure the color and see whether it's right or not is trivial. It's just cost of doing business. So everything's calibrated, and it works, and you have machines like this churning out enormous quantities of glossy advertising that you will put in the bin. On the web, on the other hand, everything is free. The content is free. The browsers are free. The design gets customized to the end user's display. If you look at something on your phone and then you look at something on a laptop, it's different. The production is therefore distributed. It doesn't happen in one place and get shipped out. It gets shipped out and then rendered. And end-user calibration is, to put it politely, rare, i.e. nobody does it. The result is therefore messy, colorful, but really not good. OK, let's look at this then. This is a module that I'm writing at the moment, CSS color module level 4. And it has all these good color management things in it. It's like, OK, come on, Chris, did you not learn? Nobody wants this. Everyone sees this as some esoteric thing nobody needs. What happened? Well, what didn't happen and we thought might help, digital photography, people have these high-end screens, and they take it and they put it in Adobe RGB, and they angst over the precise. That's a very, very tiny amount of the population. Nobody cares about that. It didn't actually move things forward. On the other hand, Apple came up with a thing called Display P3. They adapted a standard from the digital cinema industry, and they put it on their laptops. And they put it on their phones, and they put it on their watches. And all of these devices can display the same range of colors, a bigger range than sRGB. They're all calibrated in the factory. So the customer doesn't care, but they actually have that capability on their wrist or in their pocket. And other manufacturers as well, with less promotion and less accuracy and attention to detail, did similar things. And at the same time, in the entertainment industry, your likes of Netflix and whatever were putting out wide gamut stuff. So there was a general push towards that. And eventually the mobile industry caught up and had a color management system. So that's good. And then 2016, Safari supported that screenshot that I showed you. Safari immediately implemented the one bit that did display P3. Nothing else, just that bit, so they could get content. And then, of course, we did a survey. The HTTP Archive does a survey every year. Nobody was using it. Nobody. Apart from, I think there was 8 sites in the world that had like one little test. And it's like, ooh, look, I can get this color. Because nobody cares if you can only display it on Safari. You have to display it everywhere. So this is what the syntax looks like. You say what the color space is, and then you give some numbers, and these all look the same. They're just displayed in different ways. We also use a thing called hue, LCH, hue, chroma, and lightness. So you may be looking at this and thinking, this is HSL, right? No, it's not. If you look in HSL, the colors are bunched up in some areas and they're spread apart in others, and this is much more evenly distributed. And if 2 colors have the same lightness, then they actually look the same. Whereas in HSL, blue and yellow have the same lightness. No, they don't, but they have the same number. So this is how you can use it in Color 4 as well. You can also do CMYK. You can download an ICC profile and do that. So there's a whole industry that takes CSS and HTML content and produces PDFs from it. They're super excited about this. They've implemented this, and the browsers are starting to as well. OK, so basically at this point, like in the last couple of years, suddenly we're starting, this is going to take off. It's actually going to be in the browsers. What can you do once that's become a success? Well, Color 5, you can mix 2 colors. You can say what color space you're mixing them in, have the percentage of each, and it will compute the result for you. Like this. The dotted line shows the mix line. And you notice instead of going in a straight line, it's trying to keep the maximum chroma, the saturation, so that it's on that curved line there. We can also find the most contrasting color. If you want to do responsive design, but you also want to make things accessible, then you need to worry about contrast ratios. So we actually put the equation for that into the spec. So you can say, using this, you can say basically, compared to wheat, here's a list of colors, which has the best contrast. And it will work it all out for you and say that that red color has the best contrast, and that will be the result. So you can put this into your style sheet. You can play with this now in Safari Technical Preview, and it's coming to other browsers soon. All right, web fonts. This is an even more sad story. In fact, it wasn't a sad story. It had a happy ending. It just was sad for about 20 years in between, and made me wonder about getting another job. So, fonts. This same workshop, people suggested maybe we could do something about fonts. There was this particular one, I remember, font delivery for HTML documents, but there were a bunch of proposals, all mainly showing what people needed to do, not how they would do it. So I remember looking at the minutes of this, and there was a line right at the end, just before we were closing. Oh, and anyone interested in that should contact Chris Lilley and get on a mailing list, and we'll start talking about this. So we did. And by 1997, there was a public draft. I say public draft because in those days, a lot of stuff was kind of secret. That was the way standards organizations worked. So for 6 months before that, there was publications that were only available if you're a paying member. We don't work like that anymore. As soon as you have something, you have to publish it and make it publicly available. So there it was, 97. And here's an example. I cry looking at this example. It has so much good stuff in it. But basically, the idea is you point to the font, and you say what format it's in, and you say a few things about it, like the weights, the range of weights. This got condensed down eventually. It was like there's just one weight, it covers the whole range. Yeah. So that was the concept. And I went armed with this specification to a conference, ATypi, Association Typographique Internationale. They had a conference every year. I went to the one in Reading in England. And as I got closer, I could hear this sound, chink, 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 chink. I got around the corner, and there were people with little chisels hammering into stone like this and making these beautiful Roman-style inscriptions. And there were people, working with ink and plates and impressing things. There was like this huge fetishization of old traditional technology. And I'm like, hey, on the web we can have downloadable fonts and it'll be free. And they're like, get away from me. We had been talking with browser people. The browser people knew what they wanted. The type people, the people who designed fonts, knew what they wanted. They hadn't talked to us, we hadn't talked to them. We were a world apart. But it wasn't that bad. Here's a much younger version of me with some famous type people. John Hudson, Jean-François Porcher, who did the typeface for Le Monde, Liam Quinn, and me being an idiot. So yeah, we did get on, but at the same time, they were very wary. It's like, what is this guy? What are these web people trying to do? So what did we get at the end of this? We got a syntax to define a downloadable font. We got the URL to point to it, and we got some descriptors that say, is it italic? What weight is it? That sort of thing. What didn't we get? Agreement on what you pointed to. If you were Microsoft Internet Explorer, you would point to an EOT font. And the tool to make that only worked on Windows. If you were Netscape, you would point to a PFR font from Bitstream. And the tool to make that only worked on a Mac. And you had to use a different syntax because they didn't implement the CSS syntax because they thought CSS was rubbish at that point, and they were never, ever going to support it. And if you were one of the early smartphones that had SVG, you would use an SVG font, which again would not work on anything else, and it was a mess. We just couldn't get agreement on that. We also, as I said, we didn't have consensus on what the goal was. Should the font have some digital rights management in it? Should it be impossible to use a font on a different website than the one it was originally designed for, etc.? As a result, the desolation in which web fonts existed, well, people came up with bright ideas like web-safe fonts. We can assume you have at least Trebuchet and Times and this and that. We can assume, but no, we can't really assume that. And since you don't know what font people are using, meanwhile, desktop publishing and that sort of thing was using all these fancy font features, and the web was like, do you want bold or not? It was very sad. So I mentioned this need to collaborate between the font industry, the type industry, as they like to call themselves, and browsers. And one of the things that W3C does is to encourage that sort of collaboration. So I still kept going to font conferences and still engaging people to be invited experts and to talk with us. And they were still saying things like, we are the last generation of typographers. Soon the web will steal everything. We will have no means to make a livelihood. Our children will starve, etc., and it's all his fault. And meanwhile, the browser guys were saying, those font people, they want digital rights management. They want the browser to be a policeman. If we find a site and it's using a font and the font shouldn't be there, we're supposed to what? Inform the police? What are we supposed to do? We don't want to get into that at all. Eventually, it discovered that both sides had a completely caricatured version of the other side. The other side was the devil, but actually, no. When you talk to them, they didn't want that. The font people said, when a font turns up on another site, we don't know where it came from. Can we have somewhere in the font to point to the license? Just a URL embedded in the font. Oh, so now we have to... No, we don't want any policing or anything like that. We just want to point to the license so you can look at it. And if you want to buy it, you know where to buy it. Oh, okay. So we did that. So it had a little bit of compression. It used the same zlib compression that's used in HTTP and that's used in ping because it was already there and it made it easier to implement in browsers. And it had this metadata that I mentioned. And it had no DRM, and we were very keen to say it had no DRM. There's a little block at the end of a WAF file which can contain proprietary data that's just for the foundry to put it. They could put a serial number in there, they could put whatever. And the WAF specification says, you must not do anything different, whether this is there or not. You must not attempt to read it, where there's no API to read it. I mean, the one test that we had for that feature was, here are two fonts, one's got it, one's not. You fail if you don't display them identically. So that was good. And then based on that success, we produced another version, WAF2, which has better compression, 2 stages. The first stage takes the font and basically, fonts are kind of, they're an in-memory representation, and they've got all sorts of historical baggage, and the same thing said 3 different ways. And so the first stage collapses all that down into the essential information, throws out anything it can work out later. Then it compresses it, and it has the same other stuff. So this actually had a really good effect. Let me show you what it did. 2011, global usage of number of sites using web fonts, 0, 0, 0. And now 2020, well, okay, 2020 was when this graph was made. It's flattening off. 80% globally of websites use web fonts, and they use WAF2. What does that mean? That means that when you design a site, you can decide what font it's going to use and provide that font, and that means you can use its facilities to the full. This is the, what do we get when this actually works? So for example, there's all these things called open type features. This is a fairly fancy example, but you can switch this on. You don't have to type anything different. You just type the normal letters. The font will do this if you tell it to do this. This is from CSS Fonts 3. This is quite old now. Here's another example. A lot of fonts have fractions, right? They have a thing for half, 3/4. If you use that, though, people can't Google your stuff because they're not going to type in the special thing for 3/4 fraction. They're just going to go 3/4 or whatever. And no one's going to have an 86/483 fraction in their font. But by switching on this feature, it just does that by itself. And similarly, figures lining up in columns. You need that to see where you are, but you don't want to have anything on a monospaced font. So you use a thing called tabular numbers, where all of the other characters are the same, but all of the numbers use a fixed width, and so they line up properly. Also, new in Fonts 4, variable fonts. So it used to be that if you wanted a normal and a bold, that was 2 downloads. And if you wanted 8 different weights and italic and whatever, this was like 37 downloads. And you can't download that many resources. It's just going to block. So what a variable font is it covers a range. Remember I said earlier, oh, it covers a range of weights. Isn't that nice? And then it gives you whatever value you ask for. So you can download one font and use 8 different weights of subtly different things in different places in your design, and it's just one download. So that's a good thing. And also colored fonts. I mean, these were originally introduced for emoji, but there's a long tradition of using colored fonts. This is a very nice font. I like this one. It's an Indian font. This guy went to India where there's this tradition of sign painting, and he saw all these hand-painted signs. So he asked them to make fonts for him. And they said, well, we don't have computers. He said, OK, just draw them. It's fine. It's fine. I'll do the conversion. And what they delivered was these beautiful rolls of cloth with all this multicolored letters painted on them, which is what they were expecting. He's like, I can't make fonts with that. Well, now you can. And you could always do this in print, right? You just have the same thing, the same font multiple times with different bits knocked out, and you put different colors. And when it's printed, nobody knows, but you can't do that on the web. Whereas for this example, I can change that. If I type correctly, yeah, you see, you can change any of these colors here and make it something different, and it will just... So having colors in the font is fine, but when you redo your design, you don't want to have to remake the font. You want to change it from the CSS, and that's the point of this demo, is that you can actually do that. And again, that doesn't, because different fonts will have different palettes, so you need to know what font you're using. You need to have produced it and made it as available as a download before you can rely on this sort of feature. OK, so are we there yet? The cry of children everywhere going on a long journey, are we there yet? No, we're not. Have a look at this map. I'm sorry about the colors. I didn't do the map. Green is 0, and red is a high number of average weight of font per website in that country. The figure for China is 0, and the figure for Japan is extremely small. Why? A normal web font, if you compress it as a WAF, it's going to be kilobytes, maybe as big as 50K. An average font for China that covers Chinese, if you compress it well as WAF2, is going to be about 8 megabytes. The original font was probably 17 or 25 megabytes. It's not going to work. Can't do it. So all of those countries don't, with ideographic writing systems, are still not using web fonts. They're still, we assume the platform has a font called this. It's not going to work. We've been working on this the last 2 years. The idea is that the browser will send a list of characters that are on the current page and say, I want a font called this for these characters. And the server will automatically subset it. And now with subsetting, we've already had subsetting. Google Fonts does subsetting. But no, it gets the font. It's very small. Then you go to the next page. It has a few new characters. Because remember, in Chinese and Japanese, characters are more like words. So you go to a different page. It has some different words on it. And then it sends another request. It says, I've already got this. Give me more so I can display this as well. So what you actually get is a binary patch which upgrades the font you've downloaded and makes it better. So the more pages you visit, you get these little snippets coming in the background and your font gets bigger. This works. We've done it in simulation, and we're now working on the actual standard. So we think we're actually going to do that. That last remaining 20%, we can probably get that. So, some conclusions. What can we learn from this? Be aware of past efforts. When you come up with a new thing, it's probably not a new thing. Someone else has already tried to do it. Find out what they did, even if it failed, especially if it failed. Why? Why did it fail? Prototype things. Test it. Iterate. Do not sit writing a specification for 8 years and then unveil it to the world. Give your first rough drafts. Encourage other people to look at it. Prototype it just quickly. Test it out. Change it. Do not be scared of failure. I wish I'd seen this talk at the beginning of my career, believe me. I would have been so much happier in life. Fail early, fail often, fail well, and learn from it. There's several points here in this talk where I've shown you that we designed something, but we didn't realize what was actually missing, like the right hardware or that sort of thing. There was something else, and we weren't attacking the right problem. So we were never going to succeed because we weren't solving the actual problem. This is an important one. I didn't mention this earlier, but one of the reasons that the at-font face work died was because it got slower and slower and slower in committee. Eventually, we disbanded that group, and we rolled it into CSS, and it was still slow. And many years later, we found out that one of the companies, the one that was actually editing the specification, was quietly patenting what we were doing and trying to get the patents filed before the specification was released so that they would then be able to charge license fees to everyone. Luckily, I know I'm supposed to be vendor neutral, but they shot themselves in the foot. They called their technology portable font resources. And they spent the first few pages of the specification explaining that this was not a font. It was not a font. It was a portable font resource. So when they tried to apply all their patented stuff to it, we said, oh, no, we're not shipping portable font resources. We're shipping fonts. There are little perks in this life, and that was one of them. Ensure multi-vendor buy-in. I showed you with Sun and then Oracle owning Java that they limited what you could do with the technology. You could use it for this purpose. You must not use it for another purpose. If you have multiple vendors doing that, you're less likely to be susceptible to that sort of lock. And make sure there's an active community. As soon as the specification is ready, make a polyfill. Don't wait for it to come in the browsers. Make a little JavaScript thing. Maybe it only works on some of the syntax, but it lets you test it out. It lets designers get their hands on it. Open up bug reporting on like GitHub or something so that people can say, this didn't work for me, this didn't work for me. It immediately expands your available knowledge of what's going wrong with things. And work in public. Encourage participation. W3C now does everything in public. All of the working groups are public. As soon as they have a specification, they publish it. Editors' drafts are available. The report on how the implementations are failing and passing is public. Let me show you something. This is a GitHub repo. This is how we decide what we're doing in the future, what new technologies we're going to standardize. And this is just a bunch of GitHub issues and a project board. You can click on any one of those and say, this is wrong because blah, 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 or I did this other work and I think it's better. The public in general can get involved in standards even before they're standards, even while we're just messing around and seeing if this is worth doing. And this has really increased not just the speed, but the accuracy and the end result being what we actually want and something that solves a real problem. So I would encourage you all to check that out. And that's me. That's my talk. Thank you very much.